All right, so this is where we left off. We were still dealing with this El Dorado Community College, and just calculating all these different means and standard deviations. And so, right, we have transformed distributions by multiplying, by adding, and now we're at the point where we're combining distributions, right? So we're taking some distribution. I believe we're talking about distributions T and distributions U that we found out before, right? I think T was the amount of tuition at the main campus, and U was the tuition at the the downtown campus. And I don't remember what those are, and I erased them. So maybe you guys have them. The idea is if we if the random variable U is the tuition at the, and I'm not sure if this is what we did earlier, tuition at main campus. We can kind of do this without the numbers. And if T was tuition at downtown campus, then we can, let's see, like out of random variables, we're going to go capital S. We're going to call capital S the combined tuition of two students, right? If that's true, then we can define random variable S as U plus T. In which case, we would know that the mean of our random variable S is going to be the mean of our random variable U plus the mean of our random variable T, right? As well, the variance of our random variable S is going to be the variance of our random variable U plus the variance of our random variable T. And that's pretty much what that's what we get. We could calculate this stuff based on all the numbers that we had before, but because I closed the program, I don't have them. So, but basically, you would know, just plug in the numbers, right? So that's the idea of this problem, right? When we're combining random variables, we're going to be adding we're able to add their means, and we're able to add their standard deviations if the two random variables are independent of one another. So, what about the difference? Well, that was weird. Okay, so trying to grab this. What about the difference? So if we are, so we'll define the new random variable D. Random variable D is going to be the difference between tuitions, right? And then we could say that the mean of random variable D is going to be the mean of random variable T minus mean of U. And this is where you have to be careful. If you're being asked to find your standard deviation, you're going to have your variance of random variable D is going to be not the difference of these two, but the sum, right? And so then the standard deviation of random variable D of the sum of our two variants. Okay. So that's how that dies. I think we have just about 2 more left, and then we're going to move right into the next lesson. Right? We got a variety of apples that follows a normal distribution with a mean of 9 ounces and a standard deviation of 1.5 ounces. We want to know if the eggs of apples are filled randomly by selecting 12 apples. What is the probability that the sum of the weights of the 12 apples is less than 100 apples? So, what we have to do is apply the idea that if each one of these is a random variable, right? Then what we're going to be able to do is actually add these means. So if we're selecting 12, so what we'll have is, I was trying to decide on notation. So this will be our new mean. So I'll have a new mean. We'll call it. And then the same with our standard deviation, right? And there are going to be 9 of them, or 12 of them, of course, right? Our standard deviation we're going to have 1.5, 5, right? And we're going to do that 12 times. Let's see. Sorry. I have got to find the variance, some variance, and then all right. So I need. So if our standard deviation is 1.5, then our variance is 1.5 squared, which is 2.25. So then for my new variance, it's going to be 2.25 plus 2.25 plus 12 times. That's going to be variance of A. Let's figure out what each of these things are. Alright, so our variance here is going to be so that means that standard deviation will be 477. I'm just going to check something. Something seems weird to me right now. Five 5.2? Why did I get 5.2? Why did I get 27? I think I put something wrong on my calculator. 1.5 squared? 2.25. Oh, did I do 2.5? Yeah, that's what I did. Sorry, I made a typo error. So the error I made was right here. I had put 2.5. I forgot to write the 2 there. I had written 2.5. And so 2.25 squared is actually 5.06. 3. So this is what we need to do is take in 12, which is actually going to be 60.75. And then I need to take the square root. Each of those multiply times 12. And then take the square root. Alright, so that's just the groundwork, finding the mean of our new distribution, right? Of selecting 12 apples with a mean of 9 ounces. So we found our mean and our standard deviation, and now what we need to do is the actual calculate the probability. So what's the probability that it is less than 100? Well, it says that this is normally distributed, so if we add these are all going to be normally distributed, and what we're looking for then is mean of 108, probability that that the bunch that you select is less than 100. This is going to be the area of this shaded region. We'll calculate the standardized value, x minus mu divided by sigma. We will calculate that. That is going to be negative 8 divided by 7.794. Which is going to be negative 1.0 approximately. Alright, negative 1.026. And then we can go to our handy dandy calculator to calculate this using our normal CDF. So there, we fix that. That means that this is incorrect. So we're going to go negative 8 divided by 5.196, which is going to be negative 1. Approximately negative 1.54. If we round, alright, let's go to our calculator. The real calculator. Maybe that's the problem. Maybe I should have been using minus 5 the whole time. And I'll get out my calculator button. I'm going to hit menu, probability, distributions. We are going to choose normal CDF. Where our lower bound is that. That's good. We can leave it as that. Or we can put negative 10 to the 99th power if we wanted. Our upper bound is going to be 100 with a mean of 108 and a standard deviation that I finally got right as approximately 5.19. Okay, 5.6. So we get a probability of 0.062. Approximately 0.062. All right. Question answer. The next one's a really cool question. It's a bit of a brain buster, but I like it. All right. So to save time and money, People use Tinder. No. Speed dating. I heard it's all about that Bumble now. But.
Isn't that that's the one
Oh, I don't know. I just had a single friend that told me that.
my brother said that he likes Bumble more because it's like the guys get to choose. Instead of the girls always rejecting people, it's the guy that's.
Okay.
It's not.
I don't know. Come on, I just heard that it was less scandalous. There's actually more people looking to like hang out and make their personal connection rather than others. So, alright. That's been saved for posterity. There we go. Anyhow, these women are sitting in a circle. And men are spending about 10 minutes getting to know a woman before moving on to the next one. Let's suppose the height M of male speed daters follows a normal distribution. So, let's put our men. Normal distribution with a mean of 69.5 and a standard deviation of 4. And this is for men. For females, we've got a mean of 65 inches and a standard deviation of 3. So that's for females. And we want to know what the probability is that a selected male speed dater is taller than a randomly selected female speed dater with whom speed dinner? They should have dinner too while they do it. That would make it interesting. You have to eat a whole dinner in 10 minutes and get to know this person and do it over and over and over again.
I'd go just
What if you
like
were
that. Like I'd go just for 3.
Crazy.
You can tell a lot about a person.
World record time, you beat that in 5 minutes.
Yeah, I know.
Alright. So, I think that we're looking at the, let's define a new random variable D that is, let's see. So the difference of their heights is what we need to look at, right? So let's go, just so we don't wind up with a negative number, let's go male minus female. Alright. Which means then that the mean of D is going to be the mean of M minus the mean of F, and then the standard deviation, or rather, you're going to have to go with variance of D is going to be the variance of M minus the variance of.
Oh yeah.
Yeah, there was like some. Yeah.
And this is actually like exactly the type of problem that that would be like. So you would go through like a probability distribution problem, and then they would give you something like this is the last one, where it's like you really haven't gotten a lot of information. You got to kind of make some stuff up. You got to be clever about how to approach this, because you figure if one is taller than the other, right? So if I'm taller than someone, which is not very common, but if I'm taller than someone, right, the difference of our heights is going to be, like my height minus their height is going to be a positive, right? If we're the same height, then my height minus their height is going to be 0, right? So we'd like to know if he's taller. In other words, the difference of their heights then is going to be greater than 0, right? So we're looking for probability. I'm actually going to write that down. Looking for probability that the difference of heights is greater than 0. I should have probably written that over there, but hold on.
They're real cute. Let me see.
Not cute. Yeah, so in other words, I think we're looking for the probability that our random variable d is greater than 0. That's what. That's a much better way to say it. All right, so let's get the work done. Huh? Yeah, if d is their, if we're talking about their heights, right, it's the distribution of their heights. If d is the difference of their heights. Right, we define random variable m as height. Yeah, so let's get, yeah, okay, so that works. Huh? Is larger. So, and if we defined it as male minus female, right, we want that number to be positive. All right. So now we gotta go back down and we gotta calculate our mean of our random variable d, which is going to be 69.5 minus 65, which is
It's really smashing my board.
I don't know why. Oh well, I don't care. I'm not working well with calculators today for some reason. And then we'll look at our variance of d. So I'm going to have to square. So that's going to be 4 squared plus 3. Right? And don't forget, we got to add them. Even though we're finding the difference of the two between the two distributions, we have to add our standard deviations. It's very common mistake is to actually subtract. Alright, so that is going to be 16 minus 9, which is 7. All right, so we are looking. And you notice whenever I'm calculating a probability using the normal distribution, I always draw out a picture of the distribution. And you should too. So we're looking for the area of this shaded region. I'm going to go ahead and calculate a z-score, standardized value. So that's going to be x is 0, right? That's what we're looking for. I don't know where I came up with this explanation. I'm so interested in telling you rules. Mean was 4.5. So we're looking for 0. Sorry about that. I went ahead and put the x value at 7 for some reason. Alright, so our x value is 0, minus our mean, which is 4.5, divided by the standard deviation, which is approximately negative 6.643. Alright, so now we'll go to our TI Inspire and calculate this probability. So the menu. We don't want statistics, we want probability, we want distributions, and then we need normal CDF. And now our lower bound is going to be 0. Our upper bound is going to be as close to infinity as our calculator, as we can get our calculator to do. That's usually a safe one for most calculators. I think this one, since it's on my computer, I think I could go bigger, but it's not going to change the answer. Our mean was 4.5, standard deviation of 7. So we get a probability of approximately 0.74. And within all of that stuff, that's our answer. I don't know. I don't normally circle my answers, but that's how you can do it now. Looks good. There's just a lot of stuff going on there. My answer is somewhere inside of my work, so I think that's why I circled it. Usually the answer comes at the end, but for some reason when we do these, it's embedded. Alright, so that is it. That is really a lot of, I think that covers every single type of example of what you might see from a concept in 6.2, where we're dealing with transforming random variables.